case of concave lens, it is thick at its periphery, so see here, and thin in its center. Tan is nothing but opposite divided by adjacent. So what is opposite? Mn divided by OM. Substituting I and R from the equations 1 and 2, we get N1 of, this is I, that is Mn divided by OM. Here we got plus Mn divided by MC, which is equal to, and this is R. Mn divided by MC minus Mn divided by Mi. Hello everyone. Welcome to session 4 of chapter 9, Ray Optics and Optical Instruments. This is Swati from Department of Physics, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Dear children, in the last session, we have learnt about the phenomenon of light, that is refraction of light, Snell's law, as well as the consequences of refraction. So in this session, we shall learn some more interesting concepts. So we shall start from critical angle. So to understand what is critical angle, we must know about the total internal reflection. What is total internal reflection? The name or the title suggests its meaning. Total internal reflection, which means whatever the ray which is undergoing, incidenting, which will reflect completely to its surface, we'll call it as total internal reflection. So what are the conditions for this total internal reflection to happen? So the condition is the angle of incidence must be greater than critical angle. What is the meaning of critical angle? We shall see now. It is the angle of incidence in the denser medium corresponding to an angle of refraction 90 degree in a rarer medium is called as critical angle, which means the angle of incidence, it is traveling from denser medium to rarer medium. So the angle of incidence for which the angle of refraction is 90 degree. Now this is the angle of incidence for which the refraction angle is 90 degree. Say this is a normal, so the refraction angle is 90 degree. So this angle is called as critical angle. So for this total internal reflection, this is one of the condition. The angle of incidence must be greater than the critical angle, as well as the ray of light must travel from denser to rarer medium. So now we shall see the conditions of total internal reflection. A ray of light must travel from a denser to rarer medium. Angle of incidence must be greater than the critical angle. So look at this example. We have different rays traveling from denser to rarer medium, for which the angle of refraction is also different. So for this angle of incidence, you can observe, for this angle of incidence, the angle of refraction is 90 degree, which means the ray is traveling in this direction. It is not completely reflecting into the surface of its original medium. But this angle of incidence, you can observe, the angle of incidence is greater than the critical angle now. So the ray is completely coming again to the denser medium. So we will call it as total internal reflection. So these are the two conditions for total internal reflection, and the conditions are very important examination point of view. So next we shall move on to the other concept called lens. We have already studied about the mirrors in this chapter. Now we are moving forward to study about lens. So what is a lens? A lens is basically an optical medium which is bounded by either two spherical surfaces like this, or one surface spherical, the other surface is plane. So we'll call it as lens. So now if a lens is having two spherical surfaces, there are two types of lenses. As we all know, one is a convex lens, the other one is concave lens. Suppose if the convex lens is having two spherical surfaces, we'll call it as biconvex lens. Suppose if the concave lens having two spherical surfaces, we'll call it as biconcave lens. So what are the types of lens? That is convex lens and concave lens. What is the major difference between this convex and concave lens? A convex lens is thick in its middle and thin in its periphery. So you can observe it is thick in the middle and thin in its periphery, where in case of concave lens, it is thick at its periphery, so see here, and thin in its center. So this is a basic difference, and convex lens is always named as, or it is considered as, converging lens, because if a ray of light traveling from one part of the lens, so after it passes through the lens, the ray of light will converge to one point. So hence it is called as converging lens, where in case of biconcave lens, it is diverging lens. It will diverge a beam of light, and hence it is called as diverging lens. So these are the basic differences between concave and convex lens. So let us now understand the relationship between the object distance. Object distance is denoted by U, the image distance which is denoted by V, in terms of the refractive index N and radius of curvature. So here we are going to derive an expression or the relation between U, V, N and R, that is object distance, image distance, in terms of refractive index and radius of curvature. For that, I have considered a refractive index of one medium. So which means the incident ray is traveling from one medium, it is moving on to the another medium of different refractive index. Say for example, I have considered a spherical surface here, and a refractive index of this spherical surface, I'll consider it as N2, where the light is incidenting from another medium of refractive index N1. So this is my incident light. So this is the normal, and this is called as angle of incidence. Now it reaches this point, the bending of light ray takes place. So this is called as angle of refraction. So now MN is normal drawn, and OM or OP is nothing but the object distance. O is nothing but the object placed in one medium, and V is the image distance. The distance between the pole and the center of curvature is called as radius of curvature. C is the center of curvature, P is the point, or we can even call it as center of the optical surface. So now the rays are incident from a medium of refractive index N1 to the another medium of refractive index N2. So here the aperture of the surface is considered to be a very small, so that NM will be taken nearly equal to the length of perpendicular from the point N on the principal axis. So this length is considered as equal to the length of perpendicular, that is NP, at the point N on the principal axis. So this is the principal axis. So we shall now define tan theta. For small angles, we have tan of NOM is equal to, tan is nothing but opposite divided by adjacent. So what is opposite? MN divided by OM. Similarly, for this triangle NCM, so the tan NCM is equal to MN, opposite divided by adjacent, that is MC. So now when theta is very small, so we know that tan theta, if this is tan theta, then when theta is very small, it is considered to be theta. We shall forget about tan function. So we get NCM, because tan of NCM angle we have here. So we can write it as tan theta is equal to theta for small angles. So theta is NCM, which is equal to MN divided by MC. What is NCM? You can see here it is NCM, MN divided by MC. Similarly, we have NIM triangle. For this, MN divided by MI, that is opposite divided by adjacent. So for small angle, it is just NIM is equal to MN divided by MI. So now for triangle NOC, look at this triangle NOC. The exterior angle is equal to sum of interior angles is what the law of triangle we know. So in this triangle NOC, the exterior angle is I, which is equal to sum of interior angles, that is NOM plus NCM. The interior angles are alpha and gamma. You can even take it as I is equal to alpha plus gamma and derive the expression, or you can directly write it as angle NOM plus NCM, because I is the exterior angle here. So for triangle NOC, I is equal to angle NOM plus NCM. But what is NOM? According to our first equation, it is MN divided by OM. So we shall substitute that I is equal to MN divided by OM plus MN divided by MC. That is NCM is equal to, we have already defined MN divided by MC. So substituting that, we will get the equation 1, that is I is equal to MN by OM plus MN by MC. Similarly, For this angle, this is the angle of refraction as we all know. Now considering this triangle, the exterior angle, that is gamma, which is equal to r plus beta, or we can write it as, gamma is equal to r plus beta. I just want an expression for r because I've already got the expression for I, angle of incidence. Now we have to write the expression for r. So from this we can write r is equal to gamma minus beta. So what is gamma? That is NCM. So this is gamma angle, that is NCM, minus what is beta here? NIM, that is NIM. This is the exterior angle. Sum of interior angles gives us r plus beta. We want an expression for r, that is equal to gamma minus beta, which can be written as angle NCM minus angle NIM. When theta is very small, we know that tan theta is almost equal to theta. So here r is equal to, what is NCM? We have already defined, that is Mn divided by Mc, minus NIM also we have defined, that is Mn divided by Mi. So substituting that, we'll get equation 2. Now by Snell's law, we know what is Snell's law, that is N1 sin I is equal to N2 sin R. So for small angles, we shall forget the functions of sine, that is N1I is equal to N2R. Substituting I and R from the equations 1 and 2, we get N1 of, this is I, that is Mn divided by Om, here we got, plus Mn divided by Mc, which is equal to, and this is R, Mn divided by Mc minus Mn divided by Mi. Now multiply this with all the terms, so you get N1 Mn by Om plus N1 Mn divided by Mc. So take Mn common here. So you get N1 by Om plus N1 divided by Mc. Similarly here you get Mn common and you will be remaining with N2 divided by Mc minus N2 divided by Mi. So Mn gets cancelled. Now let us rearrange this Mc terms in the denominator, the common terms to one side and bring the other terms to the other side. So we get N1 divided by Om plus N2 divided by Mi, because here we have minus, when it gets transposed it becomes plus N2 divided by Mi, which is equal to N2 by Mc we already have here in the first term, minus N1 divided by Mc. Since the denominator is same, we can write it as N2 minus N1 divided by Mc, that is our third equation. Here Om, Mi and Mc represents the magnitudes of distances of object distance, image distance, as well as the radius of curvature. Now applying Cartesian sign conventions, the object is placed in the direction which is opposite to the ray of incident direction. So it is minus u, and Mi is nothing but the image distance, which is plus v, and Mc is nothing but the distance between the center and the center of curvature, which is nothing but the radius of curvature, which is positive r. So we get Om is equal to minus u, Mi is plus v, Mc is plus r. So substituting all these in the third equation, we get N1 divided by, what is Om? Om is nothing but minus u plus N2 divided by Mi is nothing but v, which is equal to N2 minus N1 divided by r. Just rearranging these terms, we get N2 by v minus N1 by u is equal to N2 minus N1 by r, is the relation between the object distance, image distance in terms of refractive index and the radius of curvature. So this derivation is very important examination point of view. You may expect this question for 5 marks. So in this session, we have learnt about the total internal reflection and what are the conditions of total internal reflection, what is critical angle, as well as the relation between the object distance, image distance in terms of refractive index and radius of curvature. In the next session, we'll come up with a new topic. So let's all meet in the next session. Until then, keep learning all of you. Thank you.